And now we are going to have Professor Lee Berger, who is going to speak about Homo naledi and Australopithecus Sediba, assessing the impact of two new fossil hominid species on our understanding of human origins. Lee, is that you?
That's me. Thank you. Thank you to the Pontifical Academy for the invitation to speak here, and I'm going to immediately give apologies to our temporary chairman for the not talking about Pan-African hominid evolution, although I'm very much aware of the need to do that. Unfortunately, these two species are confined to South Africa at this particular time. Just to refresh people, although there have been two very good introductions to the region, we're talking about an area of dolomitic limestone that occurs just outside of Johannesburg, about 30 minutes from the city. So it really is a very easy out of our houses and to work in the morning. These sites occur in cave sites, and the first site I'm going to speak of is the site of Malapa, which was discovered in 2008. It sits about 13 kilometers north of the sites of Sterkfontein that Professor Clark spoke of, and the site of Kromdraai that you just heard about. The Malapa Cave is a very tiny site so far, and it probably won't extend significantly. Its area of fossil-bearing deposits extend over about 15 meters in every direction, and we don't know the depth of deposits. In 2010, we described a new species of hominid dated to 1.97 million years of age that we called Australopithecus Sediba, based upon a whole body analysis of largely two skeletons, that had been discovered using characters that seemed to exclude it from being any of the known species at the time, and I'll speak a little bit more to that in a moment. The specimens are fairly complete. They're growing all the time. The one on the left is an adult, we interpret as a female, called MH2. The one on the right, a juvenile, that we call MH1. And I'll tell you a little bit more about its completeness with some new discoveries at the end of this talk. The combination of features that occur in this novel species distinguish it quite strongly from the high degree of variation in the largely Sterkfontein and Makapansgat assemblage. And that itself, I think, is pretty remarkable, given that we have a gracile generalized Australopithecine. It differentiates itself in its chewing mechanisms. It has very strong, forceful chewing mechanisms. It differentiates itself in its brain morphology from the endocasts that we have, as well as its dental morphology from those assemblages, as well as the East African Australopithecines. We obviously have always relied on craniodental remains, as you've heard over and over, for taxonomy, traditionally largely because that is what's been preserved, but I think the last decade particularly has seen spectacular discoveries and descriptions of more and more postcranial remains, and they're becoming more important to our sort of whole understanding. The spectacular fossil Littlefoot skeleton, I think, indicates the importance of that. The fossils from Luzon were very creatively used both postcranial and craniodental variation to look at a mosaicism that's not held accounted for in any known existing taxon. And that's true of Australopithecus Sediba as well, indicating the importance of having multiple areas of anatomy before you decide about perhaps even what genus something goes in. The shoulder girdles are relatively primitive. They are much more gracile and slightly more ape-like than we see in most of the Sterkfontein material, a very conical thorax. The pelvis is perhaps the most surprising part of this species, being actually more human-like than the flattened Australopith-like that's been interpreted for both Australopithecus afarensis as well as the Africanus, and I'll use the term sensu lato from Sterkfontein, whether there's one or more variants. Within that, they both would seem to share a relatively flattened pelvis. Sediba doesn't have that. It has a more bowl-shaped pelvis in both the juvenile male and the female. The hands are interesting in of itself, a relatively human-like wrist pattern, a very human-like proportion. In fact, in some ways, one might call it superhuman in the sense it has an extremely elongated thumb, but relatively uncurved but powerful hand gripped within it. Within that, when you look at the spine has strong sigmoid curvature, indicating its bipedalism. And surprisingly, when you look at the feet of Sediba, it is primitive, in fact, to the material that's discovered at Sterkfontein, being relatively ape-like, surprisingly so, primitive even to the calcanei, at least the back of the foot, to those discovered in Afarensis. And we've yet to really explain why that is, whether that is sort of a redevelopment of a sort of primitive morphology, or if it's a retained primitive character from a deeper ancestry. It's been mentioned several times, the importance of isotopic data. One of the things that makes Sediba, both specimens, unique is its isotopic signature. It trends strongly C3, stronger than any other fossil hominids found in southern Africa. I think there was a discussion a little earlier about the idea that Paranthropus in southern Africa had more C3. It is a C4 species, though, Paranthropus in southern Africa, with some C3 mixture, less so than the East African Paranthropus. Sediba, interestingly, is wholly C3, and both specimens are, and that differs also from the Sterkfontein hominids, and that both unifies the specimens, but also may speak to some of the important questions that are arising about niche occupation or niche differentiation of species, how you can have things that would likely be existing at the same time as the species that Jose was just speaking about. We know a great deal about Sediba, and we know very little about Sediba at the same time. We now have 6 specimens, different individuals that we relate to this species, although most of the others are represented by just a few elements at this particular stage. We know a little bit about its environment. We know that it was existing in what appears to be a mirror of a sort of alpine mist forest, yellowwood type forest. We know from phytoliths that we found in its teeth that it had a strong dietary preference for things like grass seeds, nuts. It was eating bark at time, possibly as a fallback food, but also that there were palms present. And I think all those are indicating some sort of environment that we don't have a very good grasp on, that's not described at places that are theoretically fairly contemporaneous with this, places like Kromdra. And I think these are areas that need more investigation. One of the great things about a site like Malapa, although while it's very small, I would anticipate that we would see a great many more hominids come from there. We've been excavating very slowly. Every time we open it up, we find more hominids, and I would expect that there'll be dozens of individuals of this form. It is a very homogeneous form, and there's a significant scientific literature in the refereed literature that you can turn to if you want to know more about it. The next I'm going to turn to, though, is a little more recent and perhaps of greater interest to this group in this time period, and that's the Rising Star Cave System. Remarkably, the Rising Star System is about 800 meters from the site of Swartkrans, less than 1.5 kilometers from Sterkfontein, and 2 kilometers from Kromdra. It effectively sat right under our nose, and I think you'll see, for those of you not familiar with the site, why that itself is so remarkable. It is a completely underground system of discoveries. Under that hill behind our tented camp are about 3.5 kilometers of cave systems, mostly, though, very narrow cave systems, shaft-like systems with small openings within them. So not the big cave systems like you see perhaps at places like Sterkfontein. And it's within the network of these cave systems that the discoveries around this new species, Homo naledi, that I'm going to discuss occur. Particularly, I'll focus in the first part upon one of the more famous areas. That is the discovery at the base of this chute. This is a 12-meter chute that's about 120 meters into the cave. It narrows to about 17.5 centimeters at points going down, and appears to be the only existing entrance into what we call the Naledi system of chambers. And to date, so far, it is the only known entrance that we have into this system. It is a onerous journey today. To get to it, and it likely has never been particularly easy, despite all our work to get into the system. And I know lots of people have struggled with the idea of a discovery like this in a remote chamber like that, and I'll speak to that a little bit more and talk about additional discoveries of Homo naledi in a moment that may speak to why they're back in this far chamber. We have thrown everything to try and find if there are other entrances to this, everything from ground penetrating radar to seismics, and we have yet to find any entrance that exists in the temporal frame of the assemblage that holds Homo naledi. And we have expended that effort because it does seem like a remarkable journey. But there is strong evidence developing from the excavation themselves at the base of the chute and other parts of the chamber that indeed Homo naledi was venturing into many parts of this system through what we would consider today relatively impossible journeys for a primitive hominid. And that may also speak to some technology that this species perhaps possessed. The site itself is remarkable. It was remarkable from the beginning. It's a very tiny chamber. To give you some indication, it really is no longer than about 15 meters in length. Its widest point is about 5 meters. The fossil bearing deposits occur in the upper 35 to 40 centimeters of an unconsolidated clay that occurs on the surface. In our initial work in the site, that occurred over two excavation periods of about 7 weeks. We recovered from just a surface collection and a 1 by 1 meter by 30 centimeter excavation, around 1,500 individual hominin elements. Some of those are fragmented. I'll be fair and I'll speak to that in a moment, but they did belong to, at a minimum at that time, of 15 individuals, giving you an idea of the densities of hominids that we were confronted with. We did know early on that it was an unusual hominid, but there was also a misconception amongst many people that this is a fragmented environment, and yes, there are fragments, but those fragments are often associated with each other and probably caused by both deflation of the sediments in the last several 100,000 years and also things or people walking over these sediments. But you can see here, and I mean this mirrors what Professor Clark was showing on the left-hand side. You can see this articulated hand in a sort of clutch death grip that mirrors that of Littlefoot. There are articulated feet up at the top center, other articulated hands, and also vertical bones like you see, which we interpreted at the time of the release of this as indicating that there was some time involved in the accumulation of these dense accumulations of bones. You may see work in the next 3 to 4 months coming out, maybe a little longer, that retracts some of that idea of a great deal of time being involved in this. The collection turned into something rather remarkable from this chamber that we called the Lacetti Chamber. And when we described this species, we of course didn't have a date, much to the chagrin of our acting chair right now, who chastised me in Totevel for releasing it without a date, but I'll speak to that also in a moment. Initially, we didn't have the foreface of the various crania that we had, something like 5 crania that were coming out. We had a relatively low level of what appeared to be sexual dimorphism, interpreting the slightly larger and more robust individuals, like the one you see on the left, as males, and the very small brained individuals that you see on the right and more gracile as females. The brain is very tiny, into the range and at the bottom of the range of Australopithecines. The smallest brain size around 430, 440 cubic centimeters, going up to about 550 cubic centimeters. We did report one specimen relatively recently, perhaps approaching 600, but I think that cranial capacity may be revised downward somewhat based on some new reconstructions and new work. The material was really spectacular because we had so much. Basically, every bone in the body except the hyoid represented multiple times in multiple individuals and with truly beautiful preservation. These are all single individuals that are being represented, found in articulation, as you saw in an earlier image. Unusual about the hands of Naledi were that, again, they had an extremely elongated thumb, but the first metacarpal is, in fact, autapomorphic, unlike any hominid or hominoid, in fact, that's ever been discovered. The fingers are short and is typical of all later hominids, but extremely curved, almost to the level of Archaeolophithecus in the past. The Dentition, in their papers coming out very soon in Journal of Human Evolution, is highly homogeneous. So homogeneous that, in fact, the entire assemblage overlaps almost entirely with almost no morphological variation, something that speaks probably to a close relationship of what I think it's fair to call a likely population. We found other occurrences. One we just announced recently is the Lacetti Chamber, about 110 meters away from the Naledi Chamber, a very similar occurrence, except here the bodies appear to be in alcoves in the wall. They're not in the floor of the cave. They seem to be in natural holes within the dolomitic limestone itself. One particular, but equally difficult to get to, one particularly good specimen, of which we're in the process of hopefully finding more of, appears to be a male, identical to the larger individuals that we had in the Naledi Chamber, and with finally a spectacular face. Something important for people to note, particularly those that have downloaded or produced casts off of Morphosaurus of the original reconstructions we did, we certainly did overestimate the degree of nasal prominence in Homo naledi. It's a much flatter faced and prognathic. Once you had those missing parts, we did that, I think, largely because of what we thought we were seeing, but you can see it. It too is a very flat-faced type of hominid. There are now, we recognize, multiple chambers within the Denale system and other chambers within this greater system that contain remains of Homo naledi. We now have no less than 6 different separate occurrences of Homo naledi, all in a very similar context. What that context is that they appear as clusters of associated remains very shallowly beneath the surface of the remains, all in very, very and extreme remote parts of the chamber, and in the absence, basically entirely, of other fauna. So they're sole occurrences of a single species of hominid. And I'm not sure there are many situations like that, and that, of course, has forced us to confront things. This is unpublished, but something that you'll hear about shortly. We began to recognize that many of these bodies appeared as almost features. Here we removed a feature in its entirety, and we've begun to try to move that. This occurred at the base of the chute in a talus cone, where we dug into the talus cone itself, and there we discovered, once we pulled it out and plaster jacket, inside of that was a partial skeleton of a juvenile hominid in articulation like that, which you can only see through CT scans. So very spectacular sort of occurrences of bodies in very unusual sort of situations. Overall, I think many of you will be familiar. It's a strange, again, mosaic hominid, a very primitive flared pelvis like an Australopithecine, many Homo-like characters of the cranium, dentition, both primitive and derived at the same time, a very small dentition within human size range, though, but utterly unique in its EDJ. Its shoulders are gibbon-like in its morphology, which is surprising, but as you move more distally in both the arms and legs, they become more and more human-like as you reach those very human-like but curved hands, and very human-like feet. In fact, some of the most human-like feet found outside of humans within that. There are things like stress fractures in the feet that indicate it's a long-distance walking and behavior, but unfortunately we know almost nothing about this hominid outside of the context that it's in, and that poses its own unique problems that we had. We did, of course, though, date this hominid, and I think surprisingly to many, many people predicted that this hominid, based on its morphology, would be relatively basal, either somewhere shared with a primitive Homo erectus or sharing features with or primitive to Homo habilis, whatever that is now. Within that, some features are primitive to those types of forms, some are derived, highly derived, and thus people were guessing for dates around in excess of 1 million years and potentially even in excess of 2 million years. And I don't think that was unreasonable. Of course, the dating of Homo naledi, both direct dating, but maybe importantly, a lot of people don't recognize dating of the sort of entirety of the geological formation that surrounds that narrow sedimentological belt gave us a date of around 230 to 330,000 years ago. And thus contemporaneous with where most people think that Homo sapiens were the only thing that was existing in southern Africa. So we are now faced with what appears to be a relatively primitive adaptation hominid that seems to potentially come from relatively deep time, unless it's an accumulation of a lot of sort of primitive re-evolutions that have occurred that exists far down into the late Middle Pleistocene, and of course, I'll speak to the archaeology. One of the most controversial things that we did at the time was suggest that this species was deliberately disposing of its dead within these chambers in answer to why there is only a monospecific assemblage. That was met with, to put it mildly, mixed reception within that, but I'll talk to further evidence that's coming out of that based on new discoveries. The situation has continued to repeat itself over and over again in all of these. What are important to note are the sediments within these chambers are almost wholly derived from within the chamber. Some people have argued there must be other entrances, but it wouldn't matter because it would have to be only restrictive to a single species of hominid, and furthermore, it would have to be restricted enough to allow no external sediments to come in. And that's true in each of the occurrences of this. So we are still in the same place we were, but in fact, new discoveries are probably enhancing the idea that we are looking at some sort of mortuary practice, and I'll mention it briefly at the end of the talk. Given that it is likely that we are looking at a circa 250,000-year-old small-brained hominid that morphologically fits within the sort of basal member of the genus Homo, it is surprising. It is out of time and place with, of course, the exception of Homo floresiensis, which I apologize for that not being on this particular slide, but I think you all know it would sit slightly to the right of Homo naledi and a brain size that would be slightly less than this. I think it is surprising to see an overall hominid with these very tool-capable hands, with reduced dentition, with all these sort of adaptive things that make it a potential tool user, although we are in the absence of that direct evidence at this time, sitting in that position with that cranial capacity. And that leaves us with this question that's been coming up again and again throughout this morning and this afternoon of the recognition of greater complexity and greater diversity, and draws to the questions of how far we extend the boundaries of these various species. I think one of the things that perhaps hasn't been recognized as much of the value of Homo naledi is it probably is one of the occurrences that truly strongly breaches the boundary of what most people would say would be an acceptable extension of archaic Homo sapiens or other hominids in Africa at supposedly that time. And that makes it very valuable because it likely isn't just a extreme edge of the variation of Homo sapiens, given that whole body anatomy, and given that that whole body anatomy is consistent in many, many, many individuals and different localities. But of course, I don't think that it's, many people are going to ask, well, what's its phylogenetic position? And I don't have an answer to that. And I don't think anyone really does at this particular time, and I think that's a good thing. There have been studies that I participated in and others have done looking just at the cranium, which places it as a equal candidate ancestor of Homo sapiens as Homo erectus and equally distant. There are others that tie it to more primitive hominids, but I think that it does require sort of better samples from those other hominids so we can see whole body comparisons and some patience as we sort of absorb what this means. Where I do believe it has an immediate impact, though, is on the archaeology and the way we cautiously interpret the archaeological record. And so, as you might imagine, my colleagues and I are spending a great deal of time very critically examining claimed occurrences of large-brained hominid species in that sort of temporal time period, particularly in sub-equatorial Africa, down in southern Africa. And I think it is when you have a species that's so definitive like Homo naledi to critically go back to previous areas and say, are our supposed dates of these large-brained hominids as firm as sort of maybe the textbooks would have us believe? And I would argue that they don't stand up to that at this stage. This is, of course, the cobway skull, and I know that there's work being done on the cobway skull currently with electron spin resonance to date it, and I suspect it's going to come out very much where many of us think it will come out. But I would also caution us to trust those dates. There are difficulties with hominids from poor contexts, have been subjected to extensive radiation exposure, extensive unknown contact with other things, using a very sensitive technique. And so I would be distrustful of a date in the late Middle Pleistocene confirmed of this. Not saying the morphology doesn't look like it, I'm just saying that I don't know that the date, the present technology would hold up. And I would say the same thing for fluorspad. Fluorspad, many people don't know, comes from a highly variable, radiation-rich environment, a methane spring that explodes periodically. It was unfortunately discovered in the early 20th century, and context had different meaning at that time, and its association with various lithics, I think, again, puts a question mark over it. And although it has been used recently by my colleague, Professor Blom, to argue of a Pan-African expansion of early Homo sapiens with a date around 300,000 years or so, I would again say that maybe we should table it for the time being in the discussion until we can find better large-brained archaic hominids that do that. And the reason that's so important is we are now sitting with a species that pretty certainly sits in that 200 to 300,000 year time period. And to have something like that sitting immediately proximate to it, less than say 400, 500 kilometers away, would be surprising and need some explanation. It may be true, and I think we're hearing that those things may in fact be true, but I think that the solid and multiple evidence deserves to hold for a time being as we go back and critically deal with these now very, very important dates for understanding the true nature of hominid evolution, at least in sub-equatorial Africa at this time. We do know that there are large-brained hominids at this time, and I absolutely, in these many areas, we have some very good examples of, I think, ones that hold date, and the Jebel or Hood dates, I think, are spectacular. They are north of the Sahara at this time and associated with that sort of industry. But I think we should take a paused moment, given this new evidence, and go back and critically go back through the evidence that's occurring south of the Sahara and make sure that the context of these discoveries is as good as we think it is, because it's going to weigh on the associations of the late Acheulean. I've heard Professor Clark mention many times over the year of the lack of direct association of hominids with the Acheulean and the late Acheulean in Africa. I think it's important to think about that for a moment in the presence of a small-brained hominid, as well as the earlier parts of the Middle Stone Age, and not just throw the baby out with the bathwater, so to speak, to use an American term, when we see a small-brained hominid with a very complex brain, and presume it's not capable of perhaps very complex behaviors and very complex, perhaps, lithic manufacture. So the question also arises, when did Homo naledi arise? It could have a very deep ancestry in the millions of years, and it could have remained as a ghost lineage, or it could be some spectacular evolution of a lot of primitive characters from something later. But also, what is its extinction point? We only have this one occurrence of it at this point. But those are questions to keep in mind as we move forward, because we are certain that spectacular things are going to happen in southern Africa and across other parts of Africa as we approach 150,000, 100,000 50,000 years ago that are indicating emergent complexity, but almost every one of these are in the absence of definitive large-brained hominids. And so it's, I think, quite exciting challenge to place. Some better than others, particularly as you get to places like Clossey's river mouth, but most of them in the absence of good association of large-brained hominids. There's hope. We have discovered in the last 10 years over 1,200 localities in just the Dolomitic region where we thought that there were only maybe 100 localities in the past, and all of those with great potential. Many of them in this time period, lots of them have hominid fossils in them, and we'll be working on those over the next many years. I will show you places like Malapa have great hope. This is a block we're working on now. For those of you who like the pelvis, there is a pelvis that belongs to the holotype MH1 of Australopithecus Sediba. In fact, it appears on CT scan that his entire rest of his skeleton is. And hopefully one day we'll have a specimen that can join Littlefoot in its completeness as we begin to prepare this spectacular specimen. And I'll leave you with some of the technology we're applying in this last minute to the questions of practices. And because unfortunately this is going to be transcribed. I won't give away any deep secrets that are going to be published at the end of this year, but technology is allowing us to look at the situation of Homo naledi in these different chambers and understand the context. And the context, I can assure you, is not, it's not simple. And it does lead towards an idea of very complex behavior from this relatively primitive hominid. And I think that's going to be a rule we all have to accept over the next year as we get tools pushed back, as we get odd associations with species we didn't know exist. And I do think this is perhaps one of the most challenging times because there is a sort of idea to throw one's hands up and say too much information, but it's also one of the most exciting times. Thank you very much.